Thank you for having me here today. And today I'm going to present some neuroimaging data from a group of pre-adolescents children. So as youth are transitioning from childhood to adolescence, many of them typically experience fast increases in depressive symptoms. So it is very important to develop early prevention or intervention strategies for youth depression. And in order to do that, we need to know what caused depression or the etiology. So the etiology of depression is very complicated, involving a broad range of early risk factors, including both the individual and environmental factors. For instance, children of depressed mothers or children with maladaptive early temperamental traits, or those who've been exposed to early family stress are at elevated risks for developing depression. So my question of interest is how these early risk factors ultimately lead to the outcome of depression. So in this study, I want to focus on dysphoric mood, which is a core feature of depressive symptoms, and individuals with more intense or prolonged dysphoric mood are also more likely to develop clinical depressive disorders. So I'm interested in examining the longitudinal association between these early risk factors and the neurocorrelates of dysphoric mood reactivity, specifically the functional connectivity underlying dysphoric mood. So to explore these questions, I used longitudinal data from a group of 85 youth. So when they were around 11-year-old, we collected fMRI data during induced dysphoric mood. And also, in addition to that, we also had earlier data from these youth on their mother's lifetime history of depression and on their early family stress, which was measured around age 5, and also on their early temperament measured around age 3. So for early temperament, here I focus on two temperamental traits, the temperamental positive affectivity and temperamental sadness. So temperament refers to the early emerging and relatively stable individual differences in the behavior and emotional tendencies in response to the environment. And temperamental affectivity is operationalized as the manifestation of positive or negative affect in a specific context. For instance, when playing with bubbles, some kids would appear to be very excited, while some others would show less excitement or less positive expressions. So based on the observed behaviors like this, we would say that this laughing kid has high PA, positive affectivity, and this other kid has relatively lower PA. The same applies to temperamental sadness. And overall, the lower PA or higher sadness are thought to be maladaptive and associated with the development of depression. So using this longitudinal data, I'm interested in examining how these early factors predict functional connectivity during dysphoric mood at age 11. So while collecting this fMRI data at age 11, we induced youth dysphoric mood by using an active mood induction procedure. So basically, we presented a sad movie clip from the movie The Never Ending Story. So some of you might have seen this movie. Basically, in this scenario, the boy and his horse were passing a swamp, but then the horse drowned and died, which was very sad. So while watching this movie clip, youth were told to pretend that what happened in the movie are happening in real life. And manipulation check showed that there was a significant change in youth self-reported mood after watching this movie clip, and they became more sad. They felt more sad after watching, so supporting the effectiveness of this mood induction procedure. So then I conducted functional connectivity analysis on the fMRI data by taking an RI to RI approach within a group of a priori RIs. So these RIs are taken primarily from the two networks, frontal limbic network and default mode network, both of which are closely involved in emotion processing and the development of depression. So these RIs include the prefrontal regions like dorsolateral PFC, medial PFC, and ventrolateral PFC, and limbic regions, including insula, amygdala, and hippocampus. I also included both anterior and posterior cingulate cortex, which are important parts of default mode network. So the frontal limbic network supports the processes of emotion reactivity and emotion regulation during the processing of emotional stimuli. And for adaptive emotion development, it is important to achieve a balance between reactivity and regulation, especially during active emotion processing, like when there's high reactivity, sufficient regulation is needed to downregulate this reactivity. Therefore, a weaker connectivity between the prefrontal and limbic regions is considered as maladaptive. On the other hand, the default mode network is activated during the resting state or during self-related processing, like when you are thinking about yourself. So heightened activity within default mode network during non-self-related processing is considered as maladaptive and associated with depression risk. So too much, if you're very absorbed all the time, so that's not a very healthy pattern of thinking. So back to this regression model. So I expected that these early risk factors in childhood would predict maladaptive patterns of functional connectivity during active mood induction around age 11. In addition to these main effects of each factor, I also tested whether exposure to early family stress would moderate or strengthen the associations between these other factors and functional connectivity. And in addition to the fMRI data collected during active mood induction, we also collected resting state data from the same youth. So here I used resting state data as a control condition and compared these two sets of data just to make sure that whatever would be observed during active mood induction would be reflecting a dysphoric mood reactivity rather than the intrinsic brain activity during rest. Okay, so in the results, I first found a significant main effect of maternal depression on the connectivities between immediate PFC and the bilateral regions of both amygdala and insula. So here is the plot of, sorry. Okay, so here is the plot of the indices of connectivity for these regions. So for both amygdala and insula. So basically for high-risk youth with maternal depression, they showed significantly lower or less positive connectivities between MPFC and the limbic regions compared to low-risk youth without maternal depression. And these patterns were not found in resting state data. So in the resting state data, there was no significant difference between these two groups. And similarly for age 3 positive affectivity, there was a similar pattern that age 3 positive affectivity was significant on the connectivity between left dorsolateral PFC and left amygdala. And plotting the data showed that there was a positive association between age 3 PA and the connectivity between these two regions. So although the solid line and the circles indicate the data during active mood induction. So although the effect size is not very big, but the slope of the solid line was significant, while the slope for resting state, like this dashed line and the squares, was not significant. So overall, these results suggest that these two early risk factors, maternal depression and H3 PA, lower PA at age 3, they were both associated with weaker connectivities between prefrontal regions and limbic regions, including amygdala and insula. So although different subregions of PFC were involved here. Okay, so next, there's also a significant main effect of age 3 sadness on the connectivities between posterior cingulate cortex and the left and right insula. So plotting this data showed that this time there was a positive association between H3 sadness and the PCC insular connectivity. So again, the solid line and the circles indicate the functional connectivity during negative mood induction, both of which were significant. While the slopes for resting state data, the dashed line were not significant. So as I briefly mentioned just now, PCC as part of the default mode network plays an important role in self-referential or self-related processing, while insular supports the processing of emotionally salient information. So the greater involvement of PCC here suggests that these individuals might be engaging in more self-related thoughts, or they might be thinking about themselves a lot while watching this sad movie clip. So presumably this is not a very healthy pattern if you're very absorbed whenever you're processing negative emotions. So, and also this maladaptive pattern of functional connectivity was associated with greater sadness measured at age 3. So the connectivity between PCC and left insula, like this path, was further moderated by exposure to early family stress. So here the data were plotted at 3 different levels of early family stress. So the mean level and 1 standard deviation above and below the mean. And among the 3 lines, these 2 lines, the solid line and the dotted line, they were significant, but the other dashed line was not. So the 2 significant lines indicate relatively higher level of family stress, the mean level and 1 standard deviation above the mean. So these data suggest that exposure to greater family stress measured at age 5 strengthens the association between H3 sadness and the PCC insular connectivity at age 11. And again, this pattern was not found in resting state data. And here, all 3 lines were pretty much flat. Okay. So to summarize, in this study, by using these longitudinal data with multiple measurements, I found that early risk factors were associated or predicted maladaptive patterns of functional connectivity during induced dysphoric mood. And these early risk factors included maternal risk and also temperamental PA and temperamental sadness at age 3. Specifically, we found that they were associated with weaker connectivity between PFC regions and amygdala and insula, or hyperconnectivity between PCC and insula. So there was no significant main effect of early family stress. However, exposure to greater family stress moderated or strengthened the association between H3 sadness and the PCC insular connectivity during negative mood induction at age 11. Okay, that's all my talk, and thank you for your time and attention.